In this lecture, let's see how we are going to find out the intersections for the polar equations. Okay, so the question is to find the polar coordinates of the intersection points for the given curves. There are two right here in the interval from 0 to 2 pi. Okay, the first one is the curve in polar equation. The second one is also in curve. We need to solve this algebraically. Okay, of course, if you want to draw the picture, you can use it TI-83 calculator. Okay, so let's do it first in algebraic way. We know here the first equation is 24 sine theta. That's the first one. The second one is r 8 plus 8 sine theta. If they are intersection points, then r should be equal, and then theta should be equal to. Okay, so from here, since we have r is that and r is also that, so it gives 24 sine theta equals 8 plus 8 sine theta. Okay, now what we like to do is both sides subtract 8 sine theta, 8 sine theta. Okay, then you can see right here 24 minus 8 is 16, huh? So what we get is 16 sine theta on the left, right hand side 8 stands alone. Alright, now both sides divided by 16. You then cancel this 16 upstairs and downstairs. So what we get will be sine theta equals 8 divided by 16, which is 1/2. Probably up to now we have seen many sine theta equals 1/2, many times. So then we have a theta is 30 degrees. Don't forget another one, because sine theta equals a positive value, then theta has at least two possibilities. One is 30 degrees, another is 150 degrees. Okay, now you have those two, then you may plug in back here or here. They're the same. You'll get the same answer. Okay, for theta equals 30 degrees, and then you then have a r equals 24 sine 30 degrees. That's 24 times 1/2 gives you 12. So what's the first point? You want to put radians first, 12, and then 30 degrees. So you found one. 30 degrees, 12. There is another one. Okay. Theta equals 150 degrees. And then r times 24 sine 150 degrees is also 24 times 1/2, which gives you 12. And then you have a 12, 150 degrees. Those two points. All right. Where are those 2 points? One is in the first quadrant, another is in the second quadrant. Now you think you are done, huh? Let's say you are done. Actually, you know, computer will take these 2 answers, but if the computer actually figure out deeply, they will give you one more answer. Okay, this is in algebraic way. Let's look at the picture. You will see you missed one, huh? But this should be okay for you. Look, turn on your calculator. We are already in polar coordinate. So you want to do is input 24 here, and then sine theta, close parenthesis. That's the first equation. Second one, 8 plus 8, again sine theta, close parenthesis. Okay. Let me tell you the window size. Window size. Window size for x, minimum and maximum, and y for minimum and maximum. You see right here is 24 sine theta. So you might think theta can be from -1 to +1. This will lead to r from -24 to +24. That's correct. But you know, really for x and y, you can do a little bit better than that. This is what I did. Window. You see the one x I did, it was minimum -25 and then +25. That's what I did. And then y, I actually didn't go that deep. I go as 5. And the maximum is 25. Okay. So you see minimum -5, maximum 5. Okay. Now you graph it. That's the first one. And there's the second one. Alright. Now, you see down here, this is like 30 degrees 12. This is like 150 degrees 12. It's right here. 12, 150 degrees, and 12, 30 degrees. Apparently, there is one we missed. Okay. So, for the first one, you know, when theta is 0, then you then have a r equals 24 sine 0. Sine 0 is 0. So then we get it 0. So the first one basically tells us that from here, what we get is that we have a 0, 0 on the graph. On this graph, that is the first one, like an ellipse. Okay, the second one is the one right here. What is actually the coordinate? Look, You want 8 plus 8 sine theta be 0, is better to let sine theta be -1. And then you know theta will be 3 pi over 2, give us -1. So here if theta is 3 pi over 2, okay, and then what you have will be 8 equals 8, r equals 8 sine, oh, forgot the 8 here, 8, 3 pi over 2, and there's 8 plus 8 times -1, okay, and then that will be what? That will be 0, okay, that's 8 minus 8, that's 0, okay. So let me put a remark here on 8. Okay. So this basically tells us there is another point, which is 0, 3 pi over 2. Where is this point? It's just right down on the origin. Okay. So 0, 3 pi over 2 is another one, because it doesn't matter which angle is, what you have is the radians is 0. So it's going to be 0, 0. Okay, so that will be the third solution. But if you missed this one, I guess probably is okay. Huh? So when you do your solution, you want to do algebraically, you find this one, but you know, geometrically you can find another one. But if you consider more, you may actually using the algebraic way to find it. Here are the algebraic ways. Okay, if you let r be 0, and theta has to be 3 pi over 2, which is right here. If you let r be 0, then theta has to be 0, and probably, yeah, so it's like 0, 0, but you know, it can also be pi, 0 pi, okay, because sine pi is also there, but you know, they are the same points. So that's basically the solution. Huh? Okay, I'll see you next time.